Hello everyone, welcome to the course Expansive Soil. Today's will be the 11th lecture and it will be on module 4. Here we will learn about the swelling behavior of the expansive soil, and particularly in this class we will learn about the classification and prediction of the expansive soil. In the earlier classes we learned about the method to determine the expansive behavior of the soil, like swelling potential, swelling pressure, free swelling, liquid limit. And in this class we will learn how to classify or predict the swelling behavior of the soil from those parameters. So, we will look into all these parameters one by one, or we will look into the different methods which are available one by one. The first method is Indian standard. Indian standard is one of the very few standards which actually talks about the classification of expansive soil behavior. This standard, Indian standard, mostly classify the soils based on its liquid limit, plasticity index, shrinkage index and free swell. In this, free swell means the differential free swell index, which we have already learned how to determine the free swell index of the soil. If the liquid limit is in between 20 to 35 or plasticity index is less than 12, shrinkage index is less than 15 and free swell percentage is less than 50, then the degree of expansion of the soil will be low and the soil can be termed as non-critical. If the liquid limit is between 35 to 50, plasticity index is between 12 to 23, shrinkage index between 15 to 30 or free swell percentage is 50 to 100, the degree of expansion can be medium and the soil will be termed as marginally severe soil. Similarly, if the liquid limit is around 70 to 90, plasticity index is greater than 32, shrinkage index is greater than 60 and free swell is more than 200%, the degree of expansion of the soil will be very high and the degree of severity of this soil can be termed as severe. So, this is about the Indian standard classification of expansive soil. So, in Indian standard, the soil has been classified as low, medium and high and very high based on these parameters: liquid limit, plasticity index, shrinkage index and free swell index, and depending on the degree of expansion, the soil has termed as non-critical, marginal, critical and severe. The other method which is most widely used in India was given by Sridharan and Prakash in 2000. This classification is based on the percentage expansion of the soil, which is determined in an odometer test on the sample compacted at maximum dry density and OMC and under a surcharge load of 7 kPa, and also it also takes free swell ratio of the soil into consideration. Here I need to tell that the free swell ratio is different from the DFS, that is differential free swell. In free swell ratio, the sediment volume of the soil was measured in a DI water and the sediment volume of the soil, the same soil was determined in a kerosene or CCl4 solution, and that ratio is known as the free swell ratio. So, based on the expansion in odometer test result and the free swell ratio data, the soil can be termed as non-swelling, swelling, and the soil expansivity can be classified as negligible, low, moderate and high. If the swelling potential which is measured in the odometer test is less than 1% or the free swell ratio is less than equals to 1, the soil can be termed as non-swelling soil and the expansivity of the soil will be negligible. If the swelling potential is in between 1 to 5% or the free swell ratio between 1.0 to 1.5, then the clay type or the type of clay present in the soil can be a mixture of swelling and non-swelling soil and the expansivity can be termed as low. If expansion in odometer test or the swelling potential in odometer test is more than 25, the free swell ratio is more than 4.0, the soil clay type will be a swelling type soil and the soil expansivity can be termed as very high. So, depending on the swelling potential which is determined from the odometer test by compacting the specimen at MDD and OMC and applying a surcharge load of 7 kPa and then submerging the water, if we get the swelling potential, then that can be used here. Similarly, the free swell ratio which is obtained also can be used over here to determine the swelling type of the soil and also the expansivity of the soil. Talking about different classification, it started long back. Holtz and Gibbs classified the expansive soil based on swelling potential of an undisturbed soil sample after submerging the soil and under an 1 psi load, that is approximately 7 kPa of load in an odometer test. So, based on this test result, he determined the swelling potential, and based on this swelling potential he classified the soil as low, medium, high and very high soil. Say for example, if the swelling potential is in between 0 to 10, the degree of expansion of the soil can be expected to be low. If it is in between 20 to 35, the degree of expansion can be expected as high. If it is more than 35, it will be very high. Then again we need to remember that this test was carried out on the soil which were undisturbed and were submerged in the water under a load of 1 psi or 7 kPa in an odometer. Then the other classification is given by United States Bureau of Reclamation. This method is based on the clay content which is less than 1 micrometer size, plasticity index, shrinkage limit. We know that more clay content on a soil, the specific surface area of the soil will increase and the soil will tends to absorb more water. Similarly, more plasticity index, soil will absorb more water and the degree of expansiveness will be more. The classification is based on the clay content, the plasticity index and the shrinkage limit. If the colloid content is less than 15% or plasticity index is less than 18%, shrinkage limit is less than 10%, the degree of expansion of the soil will be low and the probable swelling potential which we can get will be around less than 10%. At the same time, if the clay content is between 13 to 23, plasticity index between 15 to 28, shrinkage limit is between 10 to 20, the degree of expansion of the soil will be medium and the expected expansion of the soil will be 10 to 20%. The most critical condition arises when the colloid content is greater than 28%, plasticity index is greater than 35% and shrinkage limit is greater than 30%. In that case, the degree of expansion of the soil will be very high and the probable expansion will be greater than 30%. So, this method uses 3 parameters. One is colloid content, plasticity index and shrinkage limit, and based on this the soil has been classified either as low, medium, high or very high, and depending on whether low, medium, very high, the probable expansion can be less than 10%, 10 to 20%, 20 to 30% or greater than 30%. The next method which is also widely used is given by Seed et al. Seed et al.'s method classified the expansive soil is based on the swelling potential of remolded soil which is compacted at standard Proctor MDD and OMC and submerged in soils in water under a load of 1 psi, that is 7 kPa in an odometer. Based on this test result, the swelling potential which we can get can be linked with the degree of expansion. If the swelling potential is in between 0 to 1.5%, the soil can be termed as less or low expansive soil. If it is in between 1.5 to 5%, the soil can be termed as medium expansive soil. If the swelling potential is between 5 to 25%, it can be termed as high expansive soil. If it is greater than 25%, it can be termed as very high expansive soil. Further, the Seed et al. Result were used to determine the swelling potential by using the activity and clay fraction. This method of classification is based on the activity of the soil as well as the percentage of clay fraction present in a soil. From the previous result, the swelling potential were determined for different type of soils, and based on what is the clay fraction and activity, the soil were classified as very high, high, medium and low expansive soil based on their swelling potential here. Here if the swelling potential is more than 25, that means if in this zone the soil can be termed as very high. If the swelling potential is between 25 to 5%, that soil will fall in this zone and the soil can be termed as high swelling soil. If the swelling potential comes in between 5 to 1.5%, that means the soil will fall on this zone and the soil can be termed as medium swelling soil. If it is less than 1.5%, then the soil will be very low swelling soil. This method is based on the previous method, or the result of this method were used to determine the classification based on activity and clay fraction. The next method used were the Merwe method, which was given by Merwe in 1964. This method uses the empirical relationship between the degree of expansion, the plasticity index, the percentage clay fraction and the surcharge pressure acting on a soil. In this method, the total heave on a ground surface can be determined using this equation. The total heave at the ground surface del H equals to summation of F into P from D equals to 1 to D equals to N. So, in this method the soil has been divided into various layers. Each layer is approximately 1 feet depth, and then the del H were determined. In this equation, del H is equals to the total heave in inch on the ground surface. D is the depth of the soil layer in increment of 1 foot up to deepest level. F is the reduction factor of surcharge pressure, which can be determined using this equation. PE is the potential expansiveness in inch per foot of depth. Using this equation, we can find out this graph. In this graph, the soil has been classified as low swelled, medium swelled and high swell, very high soil by assuming different values of PE, that is PE1, PE1 by 2, PE1 by 4 and PE equals to 0. So, by assuming different PE value, we can find out what will be the soil expansive type or what can be the heave of the soil using this equation. Now, this method is based on the differential free swelling test result. In this differential free swelling test result, we know that we need to take 10 gram of dry soil and put it in water, and also another 10 gram of soil we need to put it in kerosene. Then we need to measure the volume of the soil sample in water and kerosene, and then we can determine DFS value. The measured DFS value can also indicate what will be the degree of expansiveness of the soil. If the DFS value is less than 20%, the soil can be termed as low expansive soil. If it is in between 20 to 35, the soil can be termed as medium expansive soil. If it is in between 35 to 50, the soil can be termed as high expansive soil. If it is greater than 50, the soil can be termed as very high expansive soil. So, this method is based on the differential free swelling test method, which is given by Indian standard. Another method was proposed by Altmeyer in 1955. This method is based on the shrinkage limit or linear shrinkage of the soil. In this method, the use of clay fraction was eliminated, and instead of that, the shrinkage limit and linear shrinkage was taken into consideration for determining the expansiveness of the soil. Here we can see the linear shrinkage and shrinkage limit is being used to define the probable swell or degree of expansion of the soil. If the linear shrinkage of a soil is less than 5% or the shrinkage limit is greater than 12%, the probable swell will be less than 0.5%, and the soil can be termed as low or non-critical soil. If the linear shrinkage is in between 5 and 8 or shrinkage limit is in between 10 to 12, the probable swell will be in 0.5% to 1.5%, and the degree of expansion of the soil can be termed as marginal. If the linear shrinkage is greater than 8% or the shrinkage limit is less than 10%, the probable soil will be greater than 1.5%, and the soil will be termed as critical. This method is based on the percentage finer, that is less than 75 micron particle size, liquid limit and SPT values, and this was given by Chen in 1988. These methods correlate the laboratory data, that is liquid limit, clay content, and the field data, that is the SPT value, to determine the probable expansion of the soil as well as the degree of expansion of the soil. So, this method uses 3 parameters: percentage finer, liquid limit and the standard penetration resistance, that is in blows per feet unit. If the percentage finer is greater than 95%, the liquid limit is greater than 60%, standard penetration resistance is greater than 30, the probable expansion of the soil will be greater than 10%, and the degree of expansion of the soil can be termed as very high. Similarly, if the percentage finer is in between 60 to 95%, the liquid limit is 40 to 60%, the standard penetration resistance between 20 to 30, and then the probable expansion will be 3 to 10%, and the degree of expansion can be termed as high. Similarly, if the finer content is less than 30%, the liquid limit less than 30%, the standard penetration resistance less than 10%, and the probable expansion of the soil will be less than 1%, and the degree of expansion can be termed as low. This method takes into account the percentage finer, liquid limit and SPT value. There are 2 other methods given by Raman and Chen, which uses the plasticity index and shrinkage index to classify the soil. As far as Raman, if the plasticity index is less than 12% and shrinkage index is less than 15%, the soil will be termed as low expansive soil. Similarly, if it is between 12 to 23% and shrinkage index is between 15 to 30%, it will be termed as medium expansive soil. If the plasticity index is greater than 32%, shrinkage index is greater than 40%, the soil can be termed as very high expansive soil. Chen only uses the plasticity index, and based on this plasticity index, he classified the soil as low, medium, high and very high soil. If the plasticity index is between 0 to 15%, the swelling potential of the soil will be very low. Again, if it is between 10 to 35%, it will be medium. If it is more than 35, it will be very high. Raman methods takes into consideration the plasticity index and shrinkage index, whereas the Chen method takes only plasticity index into consideration to define the swelling potential of the soil. Another method was given by Sridharan in 1977. This method is based on the liquid limit, plasticity index and in situ suction of the soil. So, these 3 parameters were used to determine the potential swell of the soil and then potential swell classification of the soil based on this potential swell. If the liquid limit is greater than 60, plasticity index is greater than 35, soil suction at natural moisture content is greater than 4 TSF, then the potential swell will be greater than 1.5 and the soil classification will be highly expansive soil. If the liquid limit is in between 50 to 60%, plasticity index between 25 to 35% and suction at natural moisture content is between 1.5 to 4 TSF, then the potential swell will be 0.5 to 1.5% and the potential soil classification will be marginally expansive soil. If the liquid limit is less than 50%, plasticity index is less than 25%, suction at natural moisture content is less than 1.5 TSF, then the potential swell will be less than 0.5% and the soil will be classified as low swelling soil. This method is based on the liquid limit and plasticity index and it was proposed by Dakshinamurthy and Raman in 1973. This is also a widely used method in India. This method takes into consideration the liquid limit and the plastic limit of the soil. Based on the liquid limit and plastic limit, here we can see few lines has been drawn based on their liquid limit. So, these lines are at 20%, 35%, 50%, 70%, 90% and these are the different zones which has been drawn here. One is a non-swelling soil, low swelling soil, medium swelling soil, high swelling soil, very high swelling soil and extra high swelling soil. In this method, if the liquid limit is between 0 to 20%, the soil will be termed as non-swelling soil. If the liquid limit is in between 20 to 35%, then if a soil falls on this zone, then the soil will be low swelling soil. If the liquid limit is in between 35 to 50% and if a soil falls on this zone, the soil will be a medium swelling soil. Similarly, 50 to 70% the soil can be high swelling soil, 70 to 90% will be very high swelling soil and greater than 90% will be extra high swelling soil. This method was proposed by Dakshinamurthy and Raman in 1973 and it classified the soil based on its liquid limit and plastic limit. Then this method classified the soil based on the mineralogical classification chart. First, this method was developed by Pearring in 1963 and then it was modified by Holt in 1969. This method of classification correlates between the clay mineralogy, the clay activity and a new parameter was used to classify the soil. That parameter is the cation exchange activity. The cation exchange activity of a soil can be defined as the cation exchange capacity divided by the clay content multiplied by 100. So, this is a new terminology which was used to classify the soil in this method, that is the cation exchange activity. Here we can see based on the cation exchange activity and activity of the soil, the different mineral present of in the soil has been determined using this technique. Here we can see these are the different zones. If a soil falls on this part based on their cation exchange activity and activity, then the monotomolite content will be more. If it is here, it will be a tabulgite. If it is fall on here, it will be illite, chlorite and kaolinite. If it is here, it will be like halloysite. This method tells us about what kind of mineral present in a soil based on their cation exchange activity and activity. The next method of classification is the classification based on COLE and activity. COLE means the coefficient of linear extensibility. This is a method of determination of shrinkage of a soil, which I will explain later on. Generally, this coefficient of linear extensibility is defined by this formula, that is del L by del LD, or it can also be related with gamma DD divided by gamma DM to the power 0.33 minus 1, where del L by del D is a linear strain relative to dry dimension, gamma DD is the dry density of open dry sample, gamma DM is the dry density of sample at 33 kPa suction. So, in this method, which I will explain while I will talking about the shrinkage behavior of the soil, in this method the soil will be dried after a particular water content and then the change in length of the soil will be determined. Based on that, the coal values or COLE value will be determined. And this method combines the engineering index properties of the soil with the cation exchange capacity. Here also the cation exchange activity parameters is used to classify the soil. This method first based on the reports of US Soil Conservative Service, the clay mineralogy of different soils collected from different part of the US were plotted on a chart drawn between cation exchange activity and activity. That means, soil collected from the different parts of US were taken and their cation exchange activity and activity were determined, and then they plotted on a chart. Then based on that chart and by knowing their different types of mineral present, the chart boundary for 4 mineral groups, that is kaolinite, illite, montmorillonite and vermiculite were drawn. Then 5 mineralogically similar regions were drawn in the chart, and then a relationship between coal and clay content was developed for each of the 5 chart region. So, once the soil has been placed in different 5 region, the coal value were determined, and then based on the coal value, clay content and this region, this zone, the soil classification was carried out, which I can show you in here. Here the soil were classified based on their mineralogical composition, then the coal value. Here we can see zone 4, zone 3, zone 1, zone 2 and zone 5. This is based on their cation exchange activity and activity. The soil were collected, then their cation exchange activity and activity were determined, then the soils different mineralogical compositions were determined, and based on this cation exchange activity and activity, the soil has been zoned into 5 different zones. Then the soil were plotted, and if the soil is in zone 1, the different clay fraction of the soil will be like smectite will be greater than 50%, illite will be non, kaolinite will be non, and there will also be no vermiculite. If the soil falls on zone 2, then the smectite content will be greater than 50%, some trace amount of illite will be present, trace to 25% of the illite amount will be there, trace means less than 5%, kaolinite will be like some trace content to 25% will be there, and no vermiculite will be there. If the soil falls on zone 3, then it will be 5 to 50% smectite, 5 to 25% illite, and kaolinite will be non and vermiculite will be non. If the soil falls on zone 5, there will be traces of smectite, illite content will be from trace to 25%, kaolinite will be 10 to 50% and vermiculite will be some trace amount will be there. Based on this classification, mineralogical content were determined like this. Once the mineralogical content were determined, then the coal values were determined, and then the coal and the percentage of clay were plotted, and then this line were drawn. So, here we can see again zone 1 to 2. If the soil falls on zone 1 to zone 2, the expansion potential will be high to very high. If the soil falls in between zone 3 to zone 4, the potential of expansion will be moderate, and if the soil falls on zone 5, the potential of expansion will be very low. That means, zone 5 soil means the soil will have this amount of mineralogical content. Zone 1 means zone 1 soil will have this amount of mineralogical content. So, based on the cation exchange capacity, then the coal value, the percentage clay value, the soil can be classified as highly expansive soil, moderate expansive soil and low expansive soil. Then another method was used that which takes into consideration cation exchange activity, and here the soil can be classified as moderate, very high to high expansive soil or low expansive soil. This method was developed from the mineralogical classification chart, but here they do not use any mineralogical composition, they only use the cation exchange activity to determine whether the soil will be very high to high expansive soil or moderate expansive soil or low expansive soil. So, these are the different kind of classification or prediction of the soil based on few parameters. Mostly you have seen all the classification are based on either their index properties or some engineering properties like swelling potential, swelling pressure or liquid limit, plastic limit or shrinkage limit, and all these methods are unique. So, here we can see that no two methods will give the same results. Say for example, there is a comparison between the chain method and Indian standard method, so which is based on the liquid limit. If the liquid limit is less than 30%, as far as chain method, the soil can be termed as low expansive soil, but IS standards gives 20 to 35% liquid limit for the soil to be termed as low expansive soil. Similarly, for very high expansive soil, the chain suggested the liquid limit should be greater than 60%, but Indian standard suggested the liquid limit should be 70 to 90%. So, here we can see even the two method uses the same parameter, the classification are not unique, they are different. Similarly, if we compare with the chain method, Holtz and Gibbs method and IS method based on the plasticity index, we can see the chain method suggests the plasticity index should be 0 to 15% for a low expansive soil. Holtz and Gibbs suggest it should be less than 20%. Indian standard suggests it should be less than 12%. Similarly, for a very high expansive soil, chain method suggests the plasticity index should be greater than 35. Holtz and Gibbs suggest it should be greater than 32, and IS standards suggest it should be greater than 32. Similarly, if we use the odometer test result, say for example, Holtz and Gibbs and Sid et al. Data, in which the swell potential were determined using an odometer test at a surcharge of 7 kPa, we can see that as far as Holt's method, if the swelling potential is less than 10%, the soil can be termed as low swelling soil. But for Sid et al. Method, it should be between 0 to 1.5. Similarly, for a medium expansive soil, the Holtz and Gibbs suggest the swelling potential should be between 10 to 20%. At the same time, Sid et al. Suggest it should be 1.5 to 5%. For very high expansive soil, Holtz and Gibbs suggest it should be greater than 30, whereas Sid et al. Suggest it should be greater than 25%. So, here we can see, although they use the same parameter, the classification uses different limiting values of liquid limit or plasticity index or swell potential. Therefore, all these classifications are not uniform. Only thing is, all this classification provides only a qualitative rating such as high, medium, low, etc., but it do not say about how much swelling can be expected. Here we can see in this graph, the 4 different methods has been compared. The swelling potential and plasticity index were used. The first you can see, this is a Holtz and Gibbs method, which uses a surcharge pressure of 1 psi, and here you can see the graph is here, the curve is here. Similarly, if we take Seed-Woodward method, which also uses a surcharge pressure of 1 psi, we can get a curve like this. If we take the chain method, which uses 1 psi pressure, the curve goes here. Similarly, if the chain takes a surcharge load 6.94 psi, then the curves will be here. So, even if we take same surcharge load, if we compare these 3 methods, we can see there is a large variation in the swelling potential of the soil at different plasticity index. So, this may be because of the initial condition. In Holtz and Gibbs method, the soil were allowed to swell from air dry to its saturated state, whereas in seed Woodward method, the remolded soil sample were used, whereas in chain method, the soil were allowed to swell from its natural moisture condition to saturation condition. So, here you can see the probable reason for this variation are like the different type of soils were used, different initial conditions were used. Initial condition means whether it is remolded or undisturbed. Initial moisture conditions were different, like whether it is wet, air dried, compacted or natural. So, depending on all these variations, the results and the classifications were also different. So, therefore, when we go for any classification, we need to see what are the different things they have taken into consideration. What are the testing methodology? What is the soil type? Therefore, when we use some classification technique, we need to first see what is the different type of soil they have used for the classification, what are the testing condition, what is the initial condition, whether it is remolded or undisturbed, what is the compaction condition, whether it is MDD or in situ density or some other density, what is the initial moisture condition from where the swelling were allowed, what is the surcharge load. So, based on this load or all these testing conditions or all these initial conditions, we have to use some method which is more identical to our conditions. So, based on those criteria, we need to select which method to adopt for classification of the soil. So, with this I will conclude this lecture here. These are the different references which are used in this in lecture, and thank you for your attention.